This video will cover everything you need to know about the switch statement. The switch statement is another control flow statement used for decision making. It's an alternative to the if statement, except it's less flexible. But I'll explain the differences later. First, let's look at how to structure a switch statement. Then I'll mention some key points and point out some common mistakes that you could possibly come across. And once we understand the switch statement completely, that's when I'll explain the difference between the switch and if statement and when to use which one. Without further ado, here's the general structure of the switch statement. It's fairly simple. We begin the statement with the keyword switch, followed by the variable that we want to test within parentheses. Then, using the curly braces, we start a code block. Within this code block is where the decision making occurs. A certain block of code is executed depending on which of the case values match the value assigned to the test variable. To write each of these cases, we start with the keyword case, followed by the value we expect, and end that line with a colon. After this, we write the block of code that we want to execute if the test variable did equal to this particular expected case value. After we finish writing the code we want to execute, we have to end the case statement with the keyword break. This is one of the branching statements. There's a separate video that goes over all the three types of branching statements. But in the context of the switch statement, the keyword break will terminate and exit the switch block to continue on with the rest of the code. In a bit, using an example, I'll show you what I mean by this and why this break keyword is needed. Just to put it into perspective, each case statement is equivalent to an if statement or an else if statement. But in a switch statement, the equivalent of the final else statement is defined using a special keyword default. This default case is for any case that's not been covered by any of the other cases before it. All of this information about the general structure of switch statements may not mean much until we actually see an example of one. So here's the first example. Say we have an integer variable called number, which is assigned to the value of 1. This will be the variable that we will be testing. So after we start with the switch keyword, we use this variable number in the parentheses following it. Then we start the code block. In the first case, we will test for the value 1. Case 1 : is the equivalent of if number equals 1. After this colon, we have to specify exactly what the program will execute, given that the value of number did equal to 1. In our case, we'll simply print out number was 1, and then we can end this case statement with a break statement. Similarly, we can write another case statement. In this case, if the value equals to 2, then we will print out number was 2. Again, end this block with a break statement. Now, I don't want to write any more case statements, so for whatever other values number can hold, the default case will take care of this. In the default case, I'll simply print out number was not 1 or 2. Again, end this block with a break statement. This code is now a perfect example of how a switch statement should look like. So, because the value of number is assigned to 1, when we run this program, we get our expected output, which prints number was 1 in the terminal. When we change the value of number to 2, again, as we expect, the code works perfectly fine, and the message number was 2 is printed out in the terminal. When we change this value to any other arbitrary number other than 1 or 2, say 24, then the default case catches this, and we get the message number was not 1 or 2. Now, just to show you what this break contributes to in terms of making this program work the way we want it to, Let's get rid of some of these break statements and see what happens. I'll remove all of the break statements and change the value of the variable number back to 2. When we run this now, where we would have expected number was 2 to be printed out, instead we get 2 print statements as outputs. Number was 2 and number was not 1 or 2. When we change the value of number to 1, we now get all 3 print statements as outputs. To understand why we get these kinds of results, we need to understand how the switch statement works with the break statements in it. When we had all of the break statements in place, the switch statement would compare the value of number to each of the cases, identifying the case that applies. In this instance, that's case 1. It will then execute the code associated with this case. As soon as we reach this break statement, the code will break out of the switch statement completely. What this means is, it would not make any more further comparisons with any of the other cases below it. But when we miss a break statement, once it hits the case and executes the code, instead of exiting the switch block once the associated code is executed, the code will continue down the switch block and execute all the other cases following it until it finally reaches a break statement or finishes executing the whole switch block. And that's exactly what happens. Because we made the mistake, and this is actually a very common mistake, that's why I'm pointing it out. Once we hit case 1 and execute the code for this, it goes down to case 2, executes the code for case 2, then goes down to the default case, executes the default code, and now that the switch block is complete, it will finally exit. So, just to reiterate this, it's a very common mistake to miss out a break statement. So, always be careful and make sure you have break statements after each case. Along with knowing what the break contributes to in the switch statement, there are some other things you need to know about the switch statement. One of the main differences between an if statement and a switch statement is that switch statements are less flexible, because we can only test for different values of the same variable. What this means is, where in the if statement we would have been able to have an if statement that checks a value for variable 1, and then another if statement that executes code based on the value of variable 2, for switch statements, every case statement under a switch statement can only check values for a single test variable. And the cases cannot be comprised of complex Boolean expressions. This includes the Boolean operators and, or, and not. This means it can get a little tedious to write a lot of different case statements. But one trick is that there is a shortcut for grouping test cases in one line. I'll show you an example of how to do this, but first let's put back all of the break statements in place. Then, when we want to group together cases, we can simply just list them one after the other like this. I'll just change the output message here to suit all the other cases, and do the same with the odd numbers, and just change the message for the default case. Now, when we run this program, with any odd number less than 10, we get the same message. When we run it with an even number less than 10, we get another common message between all of these cases. And for all other values equal to or greater than 10, the default case handles this. Another thing you need to know about switch statements is that switch statements are limited to 4 primitive types of data: char, int, byte, and short. The only non-primitive type you could use is string, but that's only if you're using JDK version 7 or any later versions of Java. This is because strings were added for switch statements later in version 7. But if statements, on the other hand, can handle every other data types. This is another way in which if statements are more flexible than switch statements. I'll show you how you can make sure you're using the right version of Java and how you can change the JDK at the very end of this video. But first, there's something I want to show you. Say we have a string variable called fruit. Using this variable, we'll construct a switch statement with the following cases. When we run this code with the variable fruit assigned to any string with all lowercase letters, we see that the program works just as we expect it to. However, when we use the same string value, which is actually one of the cases, banana, but we use a combination of lowercase letters with uppercase letters, even though the string is still banana, the switch statement doesn't recognize it because the case itself specifies banana in all lowercase letters. We could deal with this issue by writing every possible combination of lowercase and uppercase letters for each of these fruit names. But a more effective way of doing this is by using the following trick of using the built-in function to lowercase on the test variable when we specify it in parentheses in the switch statement. This function basically takes any value that we assign to the fruit variable and converts it to a new version of the string that only includes lowercase letters. As you can see, this now has fixed the problem. Any combination of upper and lowercase letters we use to write banana will now be recognized by the switch statement. But when we do this, we have to take note of how we write our case statements. Our cases have to also specify the expected value in all lowercase letters. Otherwise, we'll now have an issue where the case statement is never going to match what we input into the switch statement because the switch statement will only take in strings of all lowercase letters. We could alternatively use other built-in functions like to uppercase, but in this case, we would have to ensure that the way we specify the case statement also uses a string of all uppercase letters. Right, so that's really all you need to know about switch statements. So, as I promised, I'll now show you where you can go to check which version of Java you're currently using and to change this version if needed. Go to File, and then Project Structure. This will open up a tab where you can change your project SDK to any version after 1.7. In my case, I'm using 1.8, and change your SDK default to any version after 7. It could be 7, 8, or 9. In my case, I'm using version 8. If you haven't yet started your project and you want to change your configurations, in the opening window, once you open IntelliJ, go to Configure and then Structure for New Project. And then if you look to the drop-down menu on the left, go to Project and you come to the same window where you can again choose your project SDK and the project language level to one that's at or above version 7. So in conclusion, we'll just recap the differences between the switch and the if statement. The switch statement is less flexible than the if statement. The if statement can work with any data type, whereas the switch statement can only take the 4 primitive data types and strings. The switch statement also cannot deal with complex comparisons using Boolean operators such as and, or, and not. But I highly recommend you have a go at switch statements to see what you can use. For example, your case statements can include the addition operator, but it can't include the Boolean comparison operators, such as less than or equal to, greater than or equal to, less than or greater than operators. But again, like I said, try it out yourself to figure out what you can and what you can't use. And what's important to remember about switch statements is to always remember to add the break statement after you finish writing the code you want to execute for each case statement. So basically, when it comes to deciding whether you want to use an if statement or a switch statement, it depends on your choice of style, because they could be used for the same purpose, but it also depends on the complexity of your conditions and the number of variables you'll be testing. And that concludes this video. Thank you for watching. Please like, share, and subscribe if you found this video helpful. Comment with suggestions for future videos or any constructive criticism, and we'll be sure to reply as soon as possible.